You should note this advanced indices problem on UTME past question paper, and here I'm going to make it to be very easy for you guys. This is a question, first one gotten from a different year, this is the second question gotten from another year, and this is the third question gotten from another year. So here I'm going to work this out. You can try this too. Let me know the answer in the comment section. If you can't get it correct, just let me know. I'll make a video for that. Now here you have something of this form. They say solve for s in the following equation. This has told you that you have a power which relates to what? Indices. 2 to the power 2s minus 5, all in a bracket 2 to the power s plus 4 equals 0. Now this here represents a quadratic equation of this form: ax squared plus bs plus c equals 0. This is the representation of what? Quadratic equation. Now, for you to be able to find s, you must make this expression to look something of this form. When it looks something of this form, you can then now what? Factorize. All right. Now, there is this simple trick that you need to apply here, and you need to be very, very what? Focused. Now, if you look at this 2s, 2 to the power 2s, and 2s over here, I can have something like this, 2 to the power s in this side here. All right. So how can I do that? Remember the law that said that if a is to the power m and all of this is to the power n, this is power what? Rule. It is going to be equals to what? A to the power m multiplied by n will give what? M what? N. Here I have what? 2s, I have what? Mn. Now notice that this is equals to this, so I can split the two to have it to be a what? Power. Hence, I can also split this what? Power here to have it as what? Power. Now, from my solution, I'm going to have that. Here, I will now say 2 to the power x all to the power 2 is still the same thing, but if I use 2 to multiply by s, I'm going to have what? To the power 2s. Now, this is going to minus 5 in a bracket, 2x bracket, all right? 2 to the power s plus 4 equals 0. I just work this out to have the same thing over here. Why did I work it out to have the same thing that I have over here? This is the unknown variable, which is what? S and s. This a, b, and c are numbers, all right? Now, in this place, a that is in this place, which is a number, is an invisible one, whereby if I use 1 and multiply by this, I'll still have what? This number here. While the b, you can see bs here is what? 5. B is what? 5. And this s is what I'm trying to what? Evaluate from here. Just like s here is what I'm trying to what? Evaluate from here. Now, c is the constant, and here they are equal to what? 0. Now, for this equation to now finally look like this, I will now say that let this I have in a bracket equals a certain alphabet. It could be equals s, or it could be equals any what? Alphabet. But here, let me use what? I'm going to say let s to the power, so let's 2 to the power s equals m. All right, this here, let it be equals m. So I'm going to rewrite my expression. Wherever I see 2 to the power s, I will replace it with what? M. So from here, 2 to the power s, it now becomes what? M to the power what? Square. This is 2 to the power s, all of them is equals what? M. So I'm replacing it with what? M to the power what? Square, instead of 2s to the power what? Square. It's also minus 5 in a bracket. I have what? 2 to the power s. Just like I said, let 2 to the power s equals m. It now becomes 5 what? M. Plus what? 4 equals what? 0. Now, if you look closely, you find out that this expression has now have the identity of our what? Quadratic what? Expression. Whereby the a, like I said, is an invisible one, whereby if you use that one and multiply by m squared, it's going to have what? M squared. B is what? 5. S is now m. So I use the unknown variable, which is s, and replace with what? M. So it is still the same thing. C, which is constant, is what? 4. Now, in this case, you are now going to do what? Factorize. All right? You are going to what? Factorize to have the value of what? S. So factorizing this expression, we are now going to say opening a bracket, 2 bracket, which is going to equal 0. You're going to take the first variable with a square, just like this one with a square, and have it to be factorized, that is, making it to be in two pairs of what is going to return back to this what expression. Now, if I should say m to be here and m to be here, if I use m multiplied by m, it will give me what? M square. Now, to fill this other space over here, what do we need to do? We need to look for a number. Once we multiply that number, we get this constant here. And if we add that number together, we get the middle alphabet, which is what? B. Now, when you are doing this, you should be very careful with the what? The signs you use. Remember, if I should say 1 multiplied by 4, I'm going to have what? 4. 1 multiplied by 4 is what? 4. But if I should say 1 plus 4, it will give me what? 5. All right? And it will going to be on what? Positive 5, whereby I have what? Negative 5. If I should say, okay, let this one be 4 and let this one be 1. 4 plus 1 is going to give me what? 5. But it's going to be a positive what? 5 instead of what? Negative 5. Now, can we put sign to it? Let this be negative 4 and let this be positive 4. Negative 4 multiplied by positive 1 is going to give me what? Negative what? 4. So it has altered this constant instead of what? Positive 4. Hence, I could put negative here to have that. Negative 4 multiplied by negative 1 is going to give me what? Positive 4. That is, when negative 4 multiplied by negative 1, these signs here are going to cancel to have what? To have equals to what? Positive 4. Now, let's say that positive 4 now plus negative 4 plus negative 1 will it give me negative 5. Let's do that. Negative 4 plus bracket negative 1. What is it going to give me? Now, when you have two numbers coming together and those number has negative sign, just like we have one biscuit and one biscuit, is going to give us what? When they come together, two biscuits. So now to express this, I have minus 4 plus multiplied by negative 1 going to give me what? Negative 1 equals what? Nothing. Now, negative 4, negative 4, just like one biscuit plus one biscuit will give us what? Two biscuits. I'm going to take this negative sign here as what? Biscuits. So that 4 biscuits, when it comes together with what? One biscuit, we are going to have what? 5 biscuits. All right? Negative what? 5. So this expression is correct with this, and this is equals what? 0. Now, what this means is that each of these brackets is going to be equal 0. Hence, from here, I could now say that bracket m minus 4 is equal 0, or bracket m minus 1, this one is also equals what? 0. Is also equals what? 0. Hence, from here, I will say that looking for the value of m, minus 4 is going to cross over. I will say m is equals to minus 4 crossover will give me what? Positive what? 4. And or m is equals to what? Negative 1 crossover will give me what? Positive what? 1. So that m is equals to what? 4 and m is equals to what? 1. But in this expression, they say we should find what? Solve for s in the following what? Equation. We just introduce what? M. It is not what we are what? Looking for. Hence, we are going to return back to this expression whereby we say let 2 to the power s equals what? M. For us to now find s, we are going to what? Substitute the individual values we have for what? We have for m in this particular place here, and then we can be able to what? Solve for s. All right, so let's do that. Remember, we say that let what? Let 2s, 2 to the power s equals what? M. Now we are going to say for m equals 4. For m equals 4, what is going to be the value of s? We are not going to have to be what? 2 to the power s equals what? Instead of m, we are saying for m equals what? 4. We now replace m with what? 4. All right. Now, in this expression, we have what? Equation of what? Indices. An equation of indices, I told you that if the bases are what? Equal, the powers is going to be what? Equal. So this is a base and this is a power. And this is a base and it has a power of what? 1. All right, but in this case, I cannot get my s if these two does not have the same what base. So I must make 4 to have the same base as 2, so that if the base will be equal, the powers is going to be what equal. Now 4 could be written as 2 raised to power what 2, because 2 times 2 is what 4. That is 2 raised to power what 2. Hence, in this expression, I'm going to say that 2 to the power s is equals to what 2 to the power what 2. It's still the same thing with what 4. Now that the base is equal, the powers is going to be what equal. So that 2 is equals to, hence s will be equals what 2. Hence s equals what 2, and s is equals what 2 as an answer from where m is equals what 4. Now for where m is equals 1, what is going to happen? For where m is equals 1. So for m now, for m equals 1, what is going to be s? I'm still going to repeat this expression as what? 2 to the power s equals what? M. Now, because for m is equals 1, I need to find my what? S. I will now replace this m here with what? 1. All right. Now, since this is 1, I must make what? The base to be what? The same thing, so that the powers will going to be what? The same thing. Now, if you could recall that anything raised to power 0 is 1. For example, if 100 raised to power 0, it is equals what? 1. If 1 million raised to power 0 is equals 1. If 5 raised to power 0 equals 1. If 2 raised to power 0 is equals 1. Hence, I can replace this 1 with the number that I want it to favor as a base in this other side, which is what? 2. So I'm going to have that 2 to the power s is equals to what? 2 to the power 0. I'm replacing this one with what? 2 to the power 0, because any number less to power 0 is what? 1. So 2 to the power 0 will also give me what? This one. Now that their base is the same thing, the powers will also going to be what? The same thing. So 2 is the same thing. It means that what? The powers, which is what? S, are going to be equal to each other, which is what? S is equals what? 0. Now, our final answer is that S is equals what? 2, and S is equals what? 0. If in the option you have only single what? Answer, hence this is your correct what? Answer. But if there is something like 1 comma 2 and option A and option B, you have what? 2 comma 5, and in option C you have 2 comma 0. That means 2 comma 0 is your what? Answer. But if there is any single answer, you have your answer to be what? 2 over here. Now when you solve any expression, you have a negative number and the what? Positive number, and in the option you have only single variable as answer. Your answer is that what? Positive number. For example, if we have calculated s to be what? Equals negative 2 and positive 4, and in the option we have only one variable, which is what? Positive. That means this particular answer is what? Answer. All right, but if there are two pairs, you look for the option that has what? These two. So that is how you can be able to solve any question you have on what? Quadratic equation as an indices. Now in this expression here, it's going to be a little bit tricky, but look at what you have to know to be able to solve this one here particularly is going to be tricky. Now look at what you need to do. What you need to do is you need to bring this expression here to this side. You get me? But before you bring it, look at this power. This power here, you have 26 in a bracket 5s minus 1. We know that from this place here, this is 2s to the power 2. All right, we know that from this expression here, 5 has a power of s minus 1, which means that before this s minus 1, there is a division on it. For instance, in the law of this, the second law of Indices, say that if s 5 is to the power m and it is dividing 5 to the power n, because they are the same what? Base, and they are dividing, I'm going to call it one base, and the power will do what? Subtract each other. So this is equals what? 1 what? 5, and the power, which is m, we subtract the power, which is what? N. All right, now have you now recorded that from here now, to be able to have m minus what? N, we had already have what? 5 raised to power m and 5 raised to power n. Now, before we have s minus 1, we have already have an expression that looks like this, all this over what? 5. And this was not there. So that when I now call this 5 and this 5 the same base, I will now print this and now put what? -1. All right. So you're going to put it on the normal expression, just like what I did here over 5, that is -1. You bring it to this other side. Now, this one here, you take it to this other side, becomes -1. Once you do that, you find now the LCM of a denominator 1 and the denominator 5, which you brought here. If you find it, you work it out. When you work it out, you will now have an expression whereby you're going to bring back that -1 to this other side. When you bring it back, it now becomes +1 equals what? 0. Now you now apply this, what I have applied here. While else this other one here is easy. But if you can't get it, let me know in the comment section. But if you get it, let's see the answer in the comment section